Hello, and welcome to Sleepy Science Stories. I'm glad you found your way here, to this quiet corner of the night. Maybe you're already lying down, the room dim, the day fading softly behind you. Maybe there's a window open somewhere, and the cool air drifts across your skin like a slow tide. For the next little while, you don't need to think, or move, or reach for anything. Just breathe. Let your thoughts loosen. Let the edges of the day dissolve into calm. Above you, space unfolds, vast, patient, infinite. Stars shimmer beyond sight, planets drift in silent orbits, and deep within that stillness lies one of the universe's quietest mysteries. Tonight, we're following that mystery. We're going to the edge of everything, to the place where light disappears, where time bends, where endings and beginnings blur into one. This is the story of what happens after crossing a black hole. And maybe, along the way, it's also the story of what happens when we let go and fall gently into the unknown. If everything disappears when it crosses a black hole, then where does it go? That question has haunted scientists, dreamers, and night thinkers for decades. It sounds simple, almost childlike, yet it reaches into the deepest corners of reality. Because a black hole isn't just an object out there in space. It's a mystery about the rules that hold the universe together, and what happens when those rules collapse. So, before we fall asleep tonight, let's drift a little closer to that darkness. Not to fear it, but to understand why it calls to us. Imagine yourself looking up at the night sky. The stars shimmer gently, the Milky Way stretches across like a river of light. You feel small, but peaceful. Then, somewhere out there, in the middle of that glowing tapestry, there's a patch where the stars seem to vanish. Not because something blocks them, but because something consumes their light. That, right there, is a black hole. A region so dense, so powerful, that even light, the fastest thing in the universe, cannot escape. From far away, it doesn't look dramatic. No flames, no spinning vortex like in the movies. Just silence. A dark circle surrounded by swirls of gas and light, twisting like water around a drain. It doesn't announce itself. It waits, still, patient, and everything that comes too close falls in. But how does such a thing come to be? To understand that, we need to talk about stars, the true architects of the cosmos. Every star you see in the night sky is a battle in balance. On one side, there's gravity, pulling everything inward. On the other, there's the pressure from nuclear fusion, hydrogen turning into helium, releasing immense energy that pushes outward. As long as these two forces balance, the star shines. It breathes, it burns, sometimes for billions of years. But when a massive star, one perhaps 10 times heavier than our sun, runs out of fuel, that balance breaks. The outward push fades, and gravity wins. The core collapses under its own weight. Atoms are crushed together. Matter itself is squeezed beyond recognition. And in that final, unstoppable moment, the star implodes, its outer layers exploding in a brilliant supernova, while its heart collapses into something infinitely dense. A black hole is born. It's like nature's own paradox, the remains of a dead star that continues to shape everything around it. Let's pause for a moment here. Think about that. Gravity so strong it pulls in everything, even light. We can't see it directly, yet its presence warps everything near it. In the same way a pebble makes ripples on water, a black hole bends space and time themselves. If you could somehow float nearby, you would notice strange things. Light from distant stars would curve, as if space itself were bending around an invisible sphere. Colors would shift. time would begin to stretch. A second near the black hole might feel like hours, days, or years to someone far away. You wouldn't feel the change at first. It's subtle, slow, hypnotic, but everything you know about motion and time would start to lose meaning. That's the quiet power of a black hole. It doesn't rage like fire. It whispers like gravity. Now, there's a boundary around each black hole. We call it the event horizon. It's not a physical surface, you wouldn't bump into it, but a point of no return. Once anything crosses that line, no signal, no light, no information can make its way back out. It's like the edge of visibility in a fog, except that beyond it, the fog isn't just thick, it's the end of causality itself. To an outside observer, something falling into a black hole seems to slow down as it approaches the event horizon. It never quite crosses, just fades, dimmer and dimmer, until it vanishes. But from the falling object's own perspective, the story is very different. It crosses that boundary easily without feeling a thing. Space stretches, time distorts, but it continues to fall. Forward, inward, endlessly. Two truths existing at once, two versions of reality that can never be reconciled, and yet both are right. That's the strange beauty of Einstein's relativity. It tells us that what we perceive depends entirely on where we stand, or how we fall. You might wonder, what's actually inside that horizon? What happens to matter once it's gone beyond rescue? Does it reach a center? Does it stop? Does it get crushed out of existence? Or does it transform into something else? We don't really know. Not yet. Our best equations, the same ones that describe gravity and space-time so beautifully everywhere else, simply stop working at the center of a black hole. They return impossible answers, infinities, singularities, undefined realities. It's as if the universe itself says, "You're not meant to see beyond this point." But scientists are stubborn. They keep asking. They build telescopes, simulate collapsing stars, measure the dance of light around invisible centers, all to answer one quiet question: what lies beyond the horizon? Sometimes, I like to think of black holes not as destroyers, but as keepers of secrets. They don't erase the universe. They store parts of it somewhere we can't reach. Every piece of matter that falls in, every photon swallowed, every atom that once formed a star or planet, all of it still exists somehow inside that darkness. Not gone, just hidden, waiting for the right kind of understanding to find it again. That's what makes this topic so haunting, so endlessly fascinating. It's not just about physics. It's about limits, of knowledge, of perception, of what it means to exist. When you gaze at the image of a black hole, that dark circle surrounded by glowing light, you're not just seeing an object. You're looking at the edge of comprehension, a boundary between what we know and what we can only imagine, a frontier that invites us to cross, even if we never can. So, tonight, as you lie there listening, picture yourself drifting closer to that cosmic abyss, the stars thinning out around you, the light curving into spirals, the silence deepening until even thought seems to slow. You're safe here. This is only imagination. But it's the same curiosity that drives every scientist to peer deeper into the night, to ask the questions no one has yet answered. Maybe that's why we find black holes so strangely comforting. They remind us that even in the darkest corners of the universe, there is still mystery and meaning, still something worth reaching for. So, if everything disappears when it crosses a black hole, where does it go? Let's not rush to answer. Let's drift closer. Let's listen to the silence of gravity itself and take the first step toward the unknown. If you could drift toward a black hole, not in a spaceship, but as you are now, weightless, calm, and quiet, you'd begin to notice something strange long before you ever reached it. The stars behind you would start to stretch, their light bending around an unseen curve. Their colors would shift, reds deepening, blues fading, and time would begin to slow. At first, it's barely noticeable. Your heartbeat feels steady, your thoughts still move easily. But the deeper you drift, the more the universe seems to pull away from you. Seconds begin to stretch like elastic. Moments lengthen into eternities. And the blackness ahead feels less like emptiness and more like an ocean you're slowly sinking into. This invisible boundary you're approaching has a name: the event horizon, the edge between the visible and the unknowable, the point where gravity becomes absolute. Once you cross it, not even light, that fastest traveler in all of creation, can make its way back. It's the universe's ultimate no-return sign. But reaching it is unlike anything we've ever experienced. Because as you draw closer, the fabric of space and the rhythm of time themselves begin to twist. They no longer behave like they do out here, among the stars. Einstein predicted this strange stretching more than a century ago. He showed that gravity isn't just a force, it's the bending of space and time around mass. The more massive something is, the deeper the dent it makes in the cosmic fabric. And a black hole? It's not just a dent, it's a bottomless pit. When you're far from such a pit, time flows easily. Your seconds tick as usual. But as you move closer, the pit becomes steeper, and time slows down for you. This phenomenon is called time dilation. To you, time still feels normal. You blink, you breathe, and the moments pass smoothly. But to anyone watching from far away, you begin to move slower and slower, as if the universe were gently pressing the pause button on your existence. From their point of view, you would appear to hover at the edge, never quite falling in. Your movements would freeze. Your image would fade. The light you emit stretched into longer and longer wavelengths until it disappears into black. To them, it's as if you've stopped in time, a ghost caught between motion and stillness. But from your perspective, nothing unusual happens. You continue to fall. You pass through that boundary without resistance. No walls, no flash, no warning. Only the sense that the universe behind you is vanishing faster and faster, until even the last photons from distant stars can no longer catch up. Two truths, equally real, equally valid, separated by gravity's strange illusion. To one observer, you are frozen forever at the edge. To another, you are gone, slipped silently into the unknown. As you float there, just before crossing, you might notice another wonder, light from the universe bending and looping around the black hole in impossible ways. This is gravitational lensing, one of the most beautiful distortions in physics, because gravity doesn't only pull on matter, it also bends the path of light. And near a black hole, where gravity reaches its peak, this bending becomes extreme. You'd see the universe itself wrapping around you, stars appearing in multiple places at once, rings of light circling the darkness, a cosmic mirage, elegant and unsettling. This is how we can see a black hole even when no light escapes it, not by looking into it, but by observing how it bends the light of everything around it. It's a lens not made of glass, but of gravity. The first image of a black hole, that glowing ring around a dark center, is exactly this illusion. Each photon in that picture had been pulled, twisted, and delayed by billions of tons of warped space-time. What we're seeing is not the black hole itself, but the dance of light trying and failing to escape it. And in that dance lies a kind of poetry, because even as the black hole devours light, it also shapes it. Even in darkness, there's creation. But let's return to your fall. From your own frame of reference, the world behind you accelerates away. Galaxies stretch into thin lines of light. Time outside seems to race ahead. Stars live and die in the blink of your eye. The entire future of the universe unfolds as you drift closer to the horizon. And then, for you, it's over in an instant. You cross the boundary, effortlessly, silently. You've entered a region where time and space trade roles, where moving forward in space is the same as moving forward in time. Every path, every possibility leads inward. You can't stop. You can't turn back. You are being carried by space-time itself. It's no longer you falling. It's the universe falling with you. Outside, though, your story looks very different. From the viewpoint of a distant observer, you never actually cross the event horizon. You hover there, frozen at the edge forever. Your light fades, stretched thinner and thinner, until it becomes too faint to see. They will wait an eternity for you to fall, but to them, you never do. Time, from their perspective, has abandoned you. So which version is true? Are you frozen at the edge, suspended between worlds? Or have you fallen through, swallowed by a cosmic shadow? The universe doesn't pick sides. Both are correct, depending on where you are. Relativity isn't just about how things move. It's about how reality itself depends on the observer. What's now for you may be forever for someone else. What's a second for you might be 1,000,000,000 years for them. In the space around a black hole, truth becomes fluid, bending and curving like light. The event horizon is where physics starts to whisper in riddles. It tells us that time can stretch without limit, that space can fold back on itself, that perception can be both real and impossible. And yet, there's beauty in that confusion, because it means we've reached the edge of understanding, the line between what we know and what we feel. In that sense, the event horizon isn't just out there, around a black hole. It's also within us, the point where curiosity meets mystery, where we sense something beyond logic and still want to reach for it. Now imagine hovering just above that horizon. No sound, no motion. The universe above you stretching endlessly, and below, an infinite fall. You look down, and you can't tell what's real anymore. Light bends back on itself, showing you distorted reflections of the stars. Your sense of direction dissolves. Up and down no longer mean anything. Even your heartbeat feels distant, like an echo from another version of you still waiting somewhere outside time. This is what it means to stand at the edge of forever, to see the universe not as a place, but as a living geometry, a shifting pattern of space, light, and time. Every photon, every second, weaving around gravity's invisible core. And maybe that's the quiet lesson of the event horizon, that what we call truth depends on where we stand, that sometimes two realities can exist at once, and both can be beautiful. So, what happens beyond this boundary? What lies past the horizon, where time ceases to flow and light can't return? We don't know. No one ever will, not from the outside. But we can imagine. And sometimes, imagination is the only light that can reach into the dark. Imagine now that we've crossed the line, that invisible horizon we've been circling so carefully. There's no sound, no sudden motion, just a soft, endless pull, gentle at first, then deeper, as if space itself were exhaling and you were being carried inward with its breath. The light around you stretches and fades. The stars behind become ribbons of color, curving and swirling like brushstrokes across the dark. Every photon you once saw now bends and folds, looping back toward the black hole's heart. Even time, that faithful companion that once kept its steady rhythm, begins to tremble. You feel it thinning, slowing, almost melting between moments. You are falling, but it doesn't feel like falling. There's no wind, no acceleration, no sense of speed. Only gravity, pure, silent, and complete, pulling not just your body, but your very sense of self. In a way, this is what physicists call free fall. If you could ignore what's happening to your surroundings, you'd feel weightless, like drifting through deep water. Einstein's relativity tells us that falling freely in gravity is the same as floating in empty space. But this isn't normal gravity. This is gravity so strong it bends the rules of reality. At first, the difference in force between your head and your feet is small. But the deeper you go, the more that difference grows. Gravity pulls harder on the parts of you closer to the center and less on those farther away. The result? You begin to stretch. They call this spaghettification. It sounds almost funny until you realize what it means. Every atom, every molecule of your body begins to feel the tug in opposite directions. Your shape elongates slowly, almost gracefully at first, but with time, the stretching becomes unstoppable. If you could look down, you'd see yourself drawn thin, like a thread unraveling toward the core. Not torn apart violently, but elongated, dissolved into a long, continuous stream of matter. A human turned to geometry. And yet, from your own point of view, you might feel nothing at all. You would simply keep falling, your senses dimming, your awareness narrowing, as space itself becomes your companion. The strange thing is, there's no floor waiting for you, no bottom of the black hole to hit. The closer you fall, the more space and time themselves stretch and twist. Distances lose their meaning. Directions collapse into one. You aren't falling through space anymore. You're falling into time. Einstein showed that near such immense gravity, time and space trade roles. What once was forward becomes downward. What once was a second becomes a distance. And once you cross the horizon, every possible future, every path you could take leads inward. You cannot stop. You cannot turn around. Even if you fired the most powerful engines ever built, you'd only move faster toward the center. Not because of momentum, but because inward is now the only direction that exists. It's like being caught in a dream where you're moving endlessly toward something you can't quite reach, a horizon that never gets closer, a destination that has no location. You feel pulled toward infinity, yet suspended, motionless, falling, and still, moving forever, and frozen in time. That paradox is what makes the black hole so haunting. It erases the line between motion and stillness, between existence and absence. If we could pause here just above the singularity and somehow describe what you'd see, it would be unlike any sight in the universe. The light from behind you would now be stretched into faint red streams. Stars no longer look like stars. The very structure of reality seems to smear together, as if the universe were being painted on an elastic sheet and you were being pulled through it. You might even glimpse echoes of yourself, distorted reflections caused by light looping around the black hole multiple times before reaching your eyes. A hall of mirrors made of gravity. Every reflection a different version of the same fall. The deeper you go, the more the outside world seems to speed away. Galaxies evolve in seconds. Stars are born and die in the blink of an eye. The universe outside the black hole runs faster and faster until its entire future passes before your eyes. From your perspective, you could see the end of everything. And yet, inside this timeless descent, your own moment never ends. A single second becomes infinite. Physicists sometimes describe this as the ultimate compression of experience. It's not that time stops for you, it's that time becomes irrelevant. Every event, every possible heartbeat, every flicker of awareness all collapse into one continuous present. The universe outside ages forever, while you remain suspended in that single instant of falling. If consciousness could persist, perhaps it would feel like floating in eternity, a kind of cosmic meditation where past and future dissolve. But in truth, no signal can return to tell us what happens next. No traveler can describe what it feels like beyond that final veil. All we have are equations and imagination. And imagination is what keeps the mystery alive. Now, picture yourself dissolving further into that darkness. The shapes, the colors, even the idea of up and down fade away. You can no longer tell if your eyes are open or closed. The only thing left is awareness, a faint hum of existence. The pull is absolute now. Not painful, not violent, just complete. You are no longer separate from the black hole. You are part of its curvature, part of its gravity, part of its silence. Space folds inward, and time folds with it. Every coordinate collapses into one. Physicists call this the singularity, a point where the laws of physics themselves stop making sense. But from your perspective, there is no point. There's only a feeling of being everywhere and nowhere at once. And maybe that's not destruction. Maybe it's transformation. Because inside this darkness, information isn't lost. It's rewritten. Matter becomes energy. Energy becomes curvature. Curvature becomes meaning, if only we could understand its language. It's strange to think, from the outside, you no longer exist. Your light has faded. Your signal is gone. To the rest of the universe, you're frozen at the horizon, erased by time. But from within, you are still falling, still alive in motion that never ends. You might ask, what's the difference between falling forever and standing still for eternity? In a black hole, those two ideas become the same thing. The distinction between before and after no longer applies. There is no later, only now. A now that stretches beyond comprehension. If you could speak, if thought could still form words, perhaps you'd whisper something like, "I'm still here." But that here would no longer mean a place. It would mean a state of being, a vibration in space-time, a memory the universe keeps within its deepest silence. And slowly, even that whisper fades, not into noise, but into calm, not into absence, but into completion. You are no longer falling into a black hole. You are the fall. You are the curvature. You are the stillness between what was and what will be. Scientists have often wondered whether there's something beyond this, perhaps another universe hidden within, perhaps a rebirth, a mirror world, or perhaps nothing at all. But whatever lies beyond doesn't matter for now, because in this moment, you've reached the limit of experience, the border where meaning dissolves into wonder. Time, distance, motion, all fade into the same silence. A silence older than stars, deeper than light, and infinitely patient. You don't need to understand it. You only need to let go. And as you drift into that final stillness, there's no fear anymore, only curiosity, stretching like light that never quite reaches the edge. When you fall deep enough into a black hole, there comes a point where words lose their grip, where the maps we've drawn, the equations we trust, the logic that's carried us this far, all begin to unravel. This place is called the singularity, the heart of darkness. A point, if it can even be called that, where the density of matter becomes infinite, and the fabric of space-time folds in on itself. It is, quite literally, the end of physics as we know it. Imagine all the mass of a star, millions of Earths' worth, crushed into a region smaller than a single atom. Gravity grows without limit. Pressure, energy, curvature all climb toward infinity. The equations of Einstein's general relativity, which so beautifully describe gravity and motion throughout the cosmos, begin to break down. They start giving answers that make no sense. It's not that Einstein was wrong, it's that his theory was never meant to describe something this extreme. General relativity tells us how space and time behave around massive objects. But here, inside the singularity, space and time are no longer around anything. They are the object. They are what's collapsing. Let's pause for a moment and try to feel that, not just understand it intellectually, but feel the strangeness of what it means. In the world we know, things have size, distance, duration. You can measure how long a second lasts, how far a meter stretches. But inside a singularity, those concepts dissolve. The distance between 2 points becomes meaningless. The idea of before and after ceases to exist. You're no longer moving through space-time. You've become part of its distortion. Einstein's theory paints a clear picture of what happens to space-time outside the singularity, how it bends, how light curves, how time slows. But when it tries to look inside, the math shatters. The numbers reach infinity. The curvature of space-time becomes undefined. The equations return silence, as if the universe itself refuses to be written there. Physicists often describe this as a divergence. It's the mathematical way of saying, this is where our understanding ends. And that's both terrifying and beautiful, because it reminds us that even the most powerful human minds, even Einstein himself, must eventually face the boundary of knowledge. But singularity is not just a mathematical glitch. It's a question, a challenge to our entire view of reality. It asks, is infinity real, or is it simply what we see when our tools break? In physics, infinities usually mean something's wrong. They tell us the model is incomplete, that there's a deeper layer we haven't yet uncovered. The singularity might not be a place that truly exists. It might be the signpost pointing toward a new kind of physics. To understand it, we need to bring another framework into play, one that governs the universe at its smallest scales: quantum mechanics. Where Einstein's relativity rules the very large stars, galaxies, space-time itself, quantum theory rules the very small atoms, particles, the invisible fabric of energy that makes everything vibrate. Each theory works perfectly in its own domain. But put them together and they start to argue. General relativity says space-time is smooth and continuous. Quantum mechanics says everything is discrete, jittery, probabilistic. Relativity deals in curves and geometry. Quantum physics deals in chance and uncertainty. When we try to describe what happens at the singularity where the universe is both incredibly massive and unimaginably small, the two theories begin to fight. Their equations refuse to speak the same language. The result is chaos not just in the math, but in meaning itself. For decades, scientists have tried to reconcile them to write a single theory of everything. They've explored ideas like quantum gravity, string theory, and loop quantum gravity, each an attempt to describe how space-time behaves when it's both curved by gravity and grainy at the quantum level. Some believe that inside a black hole, matter doesn't collapse to a point at all. Instead, it might compress to a tiny, finite region, a kind of quantum core, where the rules of both relativity and quantum mechanics merge. Others imagine that the singularity could be a bridge, a doorway to another region of space-time, perhaps even another universe. But so far, these remain ideas, mathematical whispers of possibilities we can't yet test. No signal escapes to confirm or deny them. The singularity keeps its silence. There's a poetic irony in that. The black hole, the most extreme object in the universe, doesn't shout its existence, it hides it. It conceals not only matter and light, but also truth itself. It's as if the universe has tucked away its greatest secrets at the one place we can never reach. Maybe that's why black holes fascinate us so deeply, because they are both destruction and mystery, both an end and a beginning, both silence and the echo of something more. If we could somehow stand outside of time, watching matter fall inward, we would see the collapse never finish. From our view, the falling star freezes near the horizon, its image fading, but never crossing. Yet, from within, that same collapse completes in an instant. Two realities again, both true, both irreconcilable. The singularity lies at the intersection of those truths. It's not just the collapse of a star, it's the collapse of our understanding of reality. Einstein himself once suspected that his own theory would break here. He knew that space-time couldn't remain smooth forever, but he also believed nature would find a way to avoid true infinities. He trusted that the universe was self-consistent, that something deeper must take over before the math goes mad. And maybe he was right. Maybe the singularity isn't a thing at all, but a reflection of our limitations, a mirror showing us where our comprehension stops. When we say the density is infinite, what we really mean is we don't know what happens next. So what does that mean for the matter and information that falls in? Is it erased forever, transformed, encoded in ways we can't yet see? Quantum theory tells us that information can never truly be destroyed. Relativity tells us that nothing can escape. Two truths, again, and somewhere between them, the universe must find balance. Somewhere, in the silence of the singularity, those laws must merge into one. We just haven't learned how to listen yet. You can almost imagine the singularity not as a point, but as a question mark hanging quietly at the bottom of the universe. It doesn't demand answers. It simply reminds us that there are questions worth never fully solving. Because mystery is what keeps exploration alive. It's what gives meaning to science and to wonder itself. And so, as we linger here at the center of a black hole, where gravity has devoured geometry and time has lost its direction, we find ourselves face to face with the limit of human thought. Not everything that exists can be described. Not everything that can be described will exist the way we expect. The singularity is the place where these two truths meet and dissolve into something else, something beyond math, beyond observation, beyond comprehension. When Stephen Hawking first proposed it, the idea sounded almost heretical. He said that black holes weren't completely black, that, somehow, they could glow. Not brightly, not like stars, but faintly, through a strange quantum shimmer that would take billions of years to notice. This glow, he said, was caused by the laws of quantum physics themselves, and it changed everything we thought we knew about the universe. It's called Hawking radiation, and it's the key to one of the deepest mysteries in all of science, the information paradox. Let's begin with the problem. According to Einstein's general relativity, anything that crosses the event horizon, light, matter, even entire stars, is gone forever. It falls inward, compressed beyond measure, lost to the singularity. No signal, no data, no trace can return. But quantum mechanics, the framework that governs the subatomic world, tells us that information cannot be destroyed, ever. The pattern of reality, the way particles spin, the way energy flows, the way quantum states interact, is always conserved. Things can change form, but never vanish completely. If you burn a book, the paper turns to ash and smoke, but the information, the arrangement of molecules, the pattern of energy is still embedded in the particles that remain. Quantum theory insists the universe never forgets. So what happens when information falls into a black hole? Does the universe suddenly develop amnesia? If relativity is right, it disappears forever. If quantum mechanics is right, it can't. But both theories have been tested countless times, and both work perfectly. The paradox lies not in which is wrong, but in how they can both be true at once. This is the information paradox. And it's not just a detail, it's a crack in the very foundation of physics. To understand Hawking's discovery, we have to imagine what happens near the event horizon, where gravity and quantum uncertainty dance together. In the quantum view, even the emptiest space isn't truly empty. It's filled with fleeting pairs of particles and antiparticles, appearing and disappearing in perfect balance, borrowing energy from the vacuum, then annihilating each other before the universe notices. But near the edge of a black hole, something unusual can happen. One of those particles can fall in, while the other escapes. To an outside observer, it looks as if the black hole has emitted a tiny bit of energy, a faint glow. This is Hawking radiation. Over immense timescales, this process slowly drains the black hole's mass. Bit by bit, it evaporates, until one day it vanishes entirely. But that leads to an even stranger question. When the black hole evaporates, where does the information go? If the particles that fell in are gone, and the ones that escaped carry no record of what happened inside, then the information about everything that entered the black hole is gone forever, erased from the universe. And that, according to quantum physics, is impossible. This problem haunted Hawking for decades. He believed that information truly was lost, that black holes destroyed it. It was, in his words, the price of the ultimate mystery. But many physicists disagreed. They couldn't accept that the universe would break its own rule. They searched for any way for information to survive. One possibility is that the information isn't destroyed, but somehow encoded in the Hawking radiation itself, like a cosmic barcode hidden in the random noise of particles escaping the black hole. But that idea raises another puzzle. How can information that's trapped inside escape without violating relativity? Some physicists proposed black hole complementarity, the idea that information can exist in two forms at once, depending on who's observing. From the outside, information appears to be smeared across the event horizon, gradually leaking out through Hawking radiation. From the inside, the same information continues falling toward the singularity. Both realities coexist. Neither observer ever sees a contradiction, because they can never compare notes. It's as if the universe itself maintains two versions of the truth, each complete in its own frame. Sound familiar? It echoes what we saw before. How a falling object can be frozen at the horizon from one view and freely falling from another. Reality, again, depends on where you stand. But the paradox didn't end there. In 2012, a new twist appeared, something called the firewall paradox. If information truly escapes in Hawking radiation, it must be entangled quantumly connected with what's still inside the black hole. But the laws of quantum mechanics say that one particle can't be maximally entangled with two separate systems at once. Something has to give. To preserve quantum rules, some theorists suggested that the event horizon might not be smooth at all. Instead, it could be a wall of violent energy, a firewall that destroys anything crossing it. That solution saves information, but at a terrible price. It breaks Einstein's principle that falling through a horizon should feel perfectly calm. It replaces the serene darkness with a storm of quantum fire. And so the debate continues. Do we lose information, or do we lose the smoothness of space-time itself? Does reality keep its secrets, or rewrite its rules? Over the decades, Hawking himself changed his mind. In 2004, he conceded that perhaps information isn't lost after all, that it might, in some subtle way, leak out through correlations in the radiation patterns too complex for us to decode, but still there. It was a quiet surrender, not of pride, but of curiosity. Because that's what science is, not about being right, but about daring to question the impossible. Even now, the exact solution remains uncertain. New ideas from holographic principles to ADS/CFT correspondence suggest that everything inside a black hole may actually be encoded on its surface, like a cosmic hologram. That nothing truly vanishes, it only changes form. In that picture, the event horizon isn't a wall of destruction, but a screen of memory. A boundary that records every detail of what falls through, preserving the universe's perfect bookkeeping, bit by bit, forever. When you think about it, there's something profoundly human in that. We, too, are built from information patterns of atoms, sequences of memory, stories written in the language of time. And we, too, wonder. When we disappear, when our light fades, does something of us remain? If information can never be lost, then perhaps nothing ever truly ends. Perhaps what we call loss is just a change of form, a translation from one part of the cosmos to another. In that sense, we're all entangled with the universe. Every breath, every thought, woven into the grand network of being. We leave traces in light, in matter, in gravity, in the quantum ripples that never stop echoing. Maybe black holes aren't destroyers at all. Maybe they're libraries, holding the records of everything that's ever been. Their silence is not emptiness, it's protection. When you gaze into the dark center of a galaxy, you're not just looking at an abyss. You're looking at a paradox that keeps physics alive. A reminder that the universe, no matter how vast or cold, never stops keeping score. Somewhere in that glow of Hawking radiation, in the faint whispers of quantum entanglement, the past still exists, folded, encrypted, but eternal. And maybe that's the quiet truth hidden in the heart of this mystery. If information can never be destroyed, then maybe neither can we. For a long time, we thought black holes were eternal, that once they formed, they would remain forever unmoving, unchanging, swallowing everything that dared to come close. They were, in our imagination, the immortal giants of the cosmos, the last survivors of time. But then Stephen Hawking showed us something different. He told us that even the darkest things in the universe can fade. That black holes, too, can die. To understand how, we have to start with something simple, something invisible, yet everywhere. Even what we call empty space is not truly empty. It seethes with tiny fluctuations, pairs of particles and antiparticles appearing and vanishing faster than any eye or instrument could ever detect. They are the quantum foam, the background whisper of existence. Normally, these pairs annihilate each other, instantly returning their borrowed energy to the vacuum and leaving no trace. But near the edge of a black hole at the event horizon, things change. Imagine one of those particle pairs forming just beside the horizon. One particle falls inward, the other escapes outward before they can reunite. From the outside, it looks as if the black hole has emitted a tiny piece of energy, a faint breath of radiation. It's not light from within. Nothing escapes from inside, but a new creation born just at the edge, stealing a fragment of the black hole's mass to exist. Each time this happens, the black hole grows ever so slightly lighter. Each particle that escapes is like a grain of sand carried away by the tide of quantum chance. That faint glow is what we now call Hawking radiation. This process is unimaginably slow. For a black hole the mass of the Sun, it would take about 10 to the power of 67 years to evaporate completely, a number so vast that even the age of the universe, 13.8 billion years, feels like a heartbeat in comparison. But still, the process is real. Every second, every eon, a black hole leaks a little of itself away. Not through violence or explosion, but through patience and almost imperceptible surrender. You can think of it as a kind of cosmic exhalation. The black hole, once a devourer of light, becomes a giver of light, returning to the universe what it had taken in silence. Hawking's insight was radical because it gave black holes a kind of mortality. They were no longer perfect prisons. They were burning slowly, not with fire, but with time. Imagine it. A black hole glowing faintly in the darkness, not from heat or fusion, but from the delicate interplay between gravity and quantum uncertainty. Each photon that escapes is a note in a symphony that lasts trillions of years. And as the black hole shrinks, it glows brighter, its temperature rising as its size decreases. Near the end, it burns not in silence, but in a final flash, a burst of radiation so intense that it releases all that was once trapped within. After that, nothing remains. Or perhaps everything remains in a different form. It's hard to picture this, because black holes have always felt like the universe's anchors, the things that hold galaxies together, that outlast the stars. To imagine one fading feels like imagining time itself unraveling. But that's the truth Hawking revealed. Nothing in the universe lasts forever. Not stars, not galaxies, not even these monuments of gravity. Everything changes. Everything flows. Even the strongest must someday let go. In a sense, Hawking radiation is like a candle. A black hole burns not from within, but from its edges slowly, gracefully, consuming itself to give off light. And though the candle shines quietly, its flame is finite. It will glow until it has nothing left to give. That's what makes it beautiful, its impermanence, its willingness to vanish so the universe can keep its balance. Even darkness must pay its debt to time. Let's pause and look at that image. A black hole, once a roaring giant, now barely whispering light into the cosmic night. Its halo flickers not with flame, but with particles too small to name. The gravity that once ruled entire stars now grows gentle, fading with each quantum sigh. Over billions upon billions of years, it becomes smaller, hotter, faster, until finally, in one last instant, it releases everything it has left. A final breath. A single, perfect flash. Then silence. And in that silence, the universe continues on. No ceremony, no witness. Just the echo of what was now spread as energy through space. The black hole, once the ultimate consumer, has become the ultimate giver. Its death feeds the cosmos with new potential. Nothing is wasted, not even the end. There's something deeply comforting about that, don't you think? The idea that even the darkest, heaviest things in the universe participate in the same cycle as everything else. Stars shine and die. Galaxies form and fade. And black holes, those perfect symbols of eternity, are not eternal after all. They are stories, too, written in time. The same law that turns starlight to ash will one day turn even gravity itself into a whisper. And yet, it's that very impermanence that makes the universe alive. We often imagine permanence as perfection, but in the cosmos, perfection lies in change. The constant rhythm of creation and dissolution is what keeps everything from stagnating. It's what allows stars to form, atoms to rearrange, life to exist. Without endings, there would be no beginnings. And so, when we think of a black hole evaporating, we're not witnessing destruction, but transformation. The universe recycles itself endlessly. Even its darkest chapters become light again. Some scientists wonder what might remain after a black hole's final breath. Does it leave behind a residue, a tiny remnant of pure energy, a seed of new creation? Or does it simply disappear, its information dissolved into the cosmic background? We don't yet know, and maybe we're not meant to, because the beauty of this story lies not in the answer, but in the patience of the process, in knowing that even eternity has its quiet end. So next time you look up at the night sky and see the spaces between the stars, remember that even those dark places are alive. They shimmer with invisible radiation. They hum with the echoes of what once was. Every shadow in the universe is, in its own time, becoming light again. And perhaps that's the lesson hidden in the heart of every black hole and in the heart of every life. Nothing lasts forever, but nothing is ever truly gone. We are all part of the same cycle, matter to energy, light to silence, existence to memory. Each of us burning slowly, like a candle against the vastness of night. And when the flame goes out, the light still travels on. What if falling into a black hole isn't the end? What if, somewhere beyond that invisible horizon, there is another door, a place where everything that vanished is reborn? For decades, physicists have dreamed about that possibility. And out of those dreams came two of the most fascinating ideas in all of science: the white hole and the wormhole. They are opposites and mirrors, echoes of the same equation seen from different sides. A black hole pulls everything in matter, light, even time itself. Nothing escapes its grasp. A white hole, in theory, does the reverse. It can't be entered, and instead of devouring, it expels, pouring matter and energy outward, as if the universe were breathing in one place and exhaling in another. If the black hole is the ultimate absorber, the white hole is the ultimate source. No one has ever seen one. They may not exist at all. But mathematically, in the same equations that describe black holes, they're possible. Einstein's field equations don't forbid them. In fact, they predict them, like a reflection hiding behind the glass. To imagine one, picture the geometry of space-time bending not inward, but outward. Where a black hole curves the fabric of reality into a well, deep, steep, and inescapable, a white hole would be a peak, a mountain of time, from which everything flows outward. Nothing can enter it just as nothing can leave its twin. Some physicists think these two might even be connected, that a black hole in one part of the universe could open on the other side as a white hole, spitting out what was once swallowed. A bridge between darkness and light, a tunnel between two realities, a wormhole. The term wormhole was first coined by physicist John Wheeler in 1957, but the concept goes back to Einstein himself. In 1935, he and his collaborator Nathan Rosen proposed that spacetime might allow bridges connections between distant regions, curving through higher dimensions. They called it an Einstein-Rosen bridge. In their equations, such a bridge could connect two black holes, or a black hole and a white hole, allowing travel between them. Of course, it would not be a simple journey. Inside that tunnel, space and time would twist in impossible ways. Distances would shorten, time could reverse, and gravity would bend light into spirals that loop endlessly. Crossing it, if it could ever be crossed, would be like stepping through the skin of reality itself. Now, close your eyes for a moment and imagine you are there, floating inside that tunnel of warped space-time. The walls are not solid, but made of pure curvature threads of light stretching into infinity. You can see both ends at once. Behind you, the black hole's mouth, swallowing starlight into darkness. Ahead, a brilliant glow, the white hole pouring it back out. You are neither falling nor flying. You are being carried, as if space itself were moving around you, folding and unfolding like fabric in the wind. For the first time since the fall began, you feel motion without direction. You are between worlds, between causes and effects, between death and creation. Scientists have long debated whether such wormholes could truly exist. In Einstein's equations, they can, but they're unstable, collapsing instantly the moment anything tries to pass through. To keep one open, you would need something extraordinary, matter with negative energy, the opposite of everything we know. It's the kind of material that bends space outward instead of inward, repelling instead of attracting. We don't yet know if such matter exists, but the universe has surprised us before. In quantum physics, there's a strange hint, something called the Casimir effect, where even empty space can exert a pressure that behaves like negative energy. It's faint, fragile, but it shows that the building blocks of reality are not fixed. If one day we could harness that, if we could shape space-time itself, then wormholes might not remain just in theory. They could become the next frontier doorways, not just across space, but across time. Imagine being able to leave one galaxy and appear in another, not after millions of years, but in an instant, or traveling backward in time, not in fantasy, but through geometry. It sounds impossible, and maybe it is. But so did flight before we understood air. So did starlight before we understood fusion. Even now, Einstein-Rosen bridges are more than science fiction. They appear in serious physics research, in models that attempt to unify gravity and quantum mechanics. Some theorists even propose that every quantum entanglement, every mysterious link between distant particles is a tiny wormhole, a microscopic bridge in space-time. If that's true, then the universe itself is woven together by countless hidden connections, threads that bind every atom, every star, every thought. We are already inside the web. we've just never seen the strings. There's something poetic in that idea, that gravity and entanglement, the two most mysterious forces we know, might be two faces of the same truth, that what looks like distance might only be a fold, that separation might be an illusion. If wormholes truly exist, then maybe the universe is not a collection of places, but a single vast continuity, a tapestry woven through unseen dimensions. And black holes, those dark hearts of galaxies, are not the ends of things, but knots in that fabric, places where space folds back on itself to connect with something else. And what of white holes? If they exist, could they be the other side of that connection, the mirror through which everything emerges again? Some cosmologists have even suggested that the Big Bang itself might have been a white hole, the outflow from a black hole in another universe, that our universe began as the echo of another's end. If that's true, then perhaps every black hole is the seed of a new cosmos, each one giving birth to its own expansion of time and light. In that picture, creation and collapse are not opposites. They are the same motion, seen from different sides of eternity. Now imagine that your fall through the black hole never truly ended, that you've been traveling through the wormhole all along, carried by the curvature of space itself. And now, finally, you see light again. It's not the same universe you left. The stars look younger. The constants of physics, the rules of nature feel slightly different, as if rewritten by another hand. You've emerged not where you began, but elsewhere. Another reality, another sky. You take a breath, if breath can still exist here, and whisper the only thing left to say. Was this the other side? Whether or not wormholes are real, they tell us something important about imagination, that it's not just fantasy, but the engine of discovery. Every idea that changes the world begins as an act of daring, a willingness to ask, what if the impossible is only something we haven't understood yet? In that sense, the dream of white holes and wormholes isn't about escaping the universe, it's about exploring it more completely. It's about accepting that reality may be far larger, far stranger than we can ever measure. So perhaps the black hole we feared isn't a tomb, but a tunnel. Perhaps the darkness we fall into isn't the end of light, but the beginning of another kind. And if we could see the universe not as a flat map, but as a living, folded thing, we might realize we've been crossing its bridges all along. Every photon that travels, every particle that entangles, every thought that connects each is its own small wormhole, a passage from one state of being to another. Maybe the cosmos doesn't need doors. Maybe it is one. Imagine this. You fall through a black hole past the horizon, past the silence, past everything you thought you knew, and instead of reaching an end, you awaken somewhere else. Not in destruction, but in creation. Not in death, but in birth. It sounds poetic, even spiritual, but to some of the world's greatest physicists, it might also be true. The idea is simple and astonishing. Each black hole could be the seed of a new universe. When a massive star collapses, its core implodes under its own gravity. For us, it looks like a death, a violent ending, a collapse into singularity. But inside that collapse, some theorists believe the process doesn't stop. Instead, it rebounds. The immense density and energy might trigger a new expansion, a new Big Bang, not in our universe, but inside the black hole itself. From the outside, we see only darkness. From the inside, a cosmos is born. This is the idea of cosmic rebirth, that the death of one star may ignite the beginning of another universe. It's a cycle too vast to witness, too intricate to prove, but beautifully consistent with the way nature works. Stars die and create elements for planets. Galaxies collide and birth new stars. Even in biology, every cell divides and continues through transformation. Why would the universe itself be any different? If life, light, and motion are never truly destroyed, only rearranged, then perhaps universes, too, are part of that same eternal rhythm. Let's imagine what that would mean. Inside the black hole, the collapse continues until matter reaches infinite density, or nearly so, then something changes. Quantum effects, normally insignificant, suddenly dominate. They resist gravity's infinite pull, creating a kind of pressure, a quantum bounce. Space-time, instead of tearing apart, reverses. From compression comes expansion. From singularity comes explosion. A newborn universe inflates outward, its own dimensions forming from the ashes of the old. To anyone inside, it would look exactly like a big bang, a flash of radiation, a sudden appearance of time, and the slow cooling that follows. Sound familiar? It should, because it describes our beginning. Could it be that our universe itself was born from the heart of a black hole in another universe? It's not just speculation, it's one of the real models explored by cosmologists today. They call it the black hole cosmology hypothesis. It suggests that every black hole creates a baby universe beyond its singularity, and that the constants of physics, the laws of nature, might vary slightly in each offspring. Each new cosmos carries a kind of genetic code from its parent. If those laws are stable, that universe might form stars and galaxies, and, in time, new black holes of its own, each giving birth again. A cosmic family tree, branching endlessly into infinity. This brings us to one of the boldest ideas in all of modern science, the multiverse. The idea that our universe is not alone, but one bubble in an endless cosmic sea. Each universe with its own laws, its own history, its own possibilities. Some expand forever, others collapse and begin again. Some may be filled with life, others may flicker and vanish in an instant. And somewhere, in one of those infinite universes, another being might be asking the same question we are now. What lies beyond our black holes? It's dizzying to think about. Every black hole we see in the night sky might be a gateway, a womb for another cosmos. Perhaps the universe isn't a single story, but an endless library, each chapter birthing the next. If that's true, then creation and destruction are not opposites at all. They are one motion inward, then outward like the pulse of a living heart. Even time itself may not be linear, but cyclical, folding endlessly between collapse and rebirth. There's a certain symmetry in it. Our own universe began in an explosion of unimaginable density, a singularity that expanded into stars, planets, and consciousness. And one day, perhaps eons from now, when all the galaxies fade and the last light dims, the black holes will remain waiting. And as they die, they may give rise to new beginnings. Their final collapse may spark the birth of new worlds, new skies, new minds asking, who are we? Where did we come from? It's a cycle that feels both scientific and sacred. Of course, no one can see beyond a black hole's horizon. No signal escapes to confirm what lies inside. To us, it's an eternal mystery, a closed curtain we can only imagine beyond. But maybe imagination is enough. Because every great leap in science begins with a question too big to answer. Perhaps black holes are the universe's way of asking itself those questions, of continuing the act of creation even through apparent endings. A way of saying, this is not the end, just another form. Some physicists have even suggested that if we could map the precise structure of spacetime inside a black hole, we might find the same equations that describe the birth of our own universe. In other words, we might be living inside the child of another cosmos. Our Big Bang might have been someone else's collapse, their dying star, our first dawn. It's a humbling, almost tender thought. That existence itself is a chain of inheritance, stretching backward and forward through eternity. We are descendants not just of stars, but of universes. If all of this is true, if every end hides a new beginning, then nothing is ever truly lost. Not matter, not energy, not even meaning. The universe would be a self-renewing story, each sentence written in the ashes of the last. And in that story, we are not spectators. We are part of the language itself. Our atoms, our light, our thoughts, they will pass through gravity's gates, through black holes and white holes, through time itself, and they will become the seeds of new worlds. Every whisper of matter a verse in the cosmic poem. So, if you find yourself wondering what happens when you reach the center, when the fall ends and the horizon closes, perhaps the answer is simple. Nothing ends. Every collapse is a doorway, every silence a breath before the next creation, every darkness a preparation for new light. Maybe the black hole isn't a tomb, but a womb. Maybe singularity isn't destruction, but transformation. Maybe the Big Bang never really happened once. It's happening all the time, everywhere, inside every collapsing heart of matter. We are inside one right now, living, breathing, wandering inside a universe that was once a single point in the dark. There are things in the universe we can't see, not because they're too far, but because they refuse to be seen. Black holes are among them. They are pure darkness, lightless, silent, hidden behind the fabric of their own gravity. And yet, somehow, we've managed to see one, or at least to reveal its shadow. In April 2019, the world paused. A single image appeared on screens across the globe, a blurry orange ring glowing softly around a dark center. That ring was the first ever image of a black hole captured by the Event Horizon Telescope, the EHT. It wasn't just a photograph. It was a triumph of imagination and collaboration. For the first time in history, humanity had seen what was once thought forever invisible. The object lay 55 million light-years away at the heart of galaxy M87, a giant black hole known as M87 star, 6.5 billion times the mass of the Sun. No single telescope could ever capture such detail. So scientists linked 8 observatories across the Earth, from the deserts of Chile to the ice of Antarctica, to form a planet-sized lens. They synchronized their instruments so precisely that they could measure variations smaller than a millionth of a degree. When the data arrived, It filled thousands of hard drives, petabytes of information that had to be flown by airplane because even the internet couldn't carry it fast enough. And after years of analysis, the image emerged. A dark core surrounded by a ring of light, the photon halo of matter orbiting near the event horizon, twisted by gravity into a glowing whirlpool. It was not a perfect circle. It was asymmetrical, tilted, distorted, alive. And yet, it was unmistakably real. That orange ring was more than just data. It was proof that Einstein's equations still held true, even in the most extreme conditions. It was a message from the edge of physics itself, whispered across millions of years. You were right. But it was also something deeper, a mirror reflecting our species' endless desire to know. Because to see a black hole is not just to capture light. It's to capture the shadow of everything light cannot reach. It's to turn absence into understanding. A few years later, in 2022, the Event Horizon Telescope revealed another image this time, of the black hole at the center of our own galaxy. Sagittarius, a star. Unlike M87 star, this one is much smaller, only about 4 million solar masses, but infinitely closer to home. It lies at the heart of the Milky Way, 26,000 light-years from Earth, hidden behind clouds of gas and dust. To capture it, scientists had to develop new methods, because Sagittarius. A star changes shape in minutes. Its ring flickers and shifts as plasma swirls at near light speed. The final image is fuzzy, but beautiful, the soft ring of our galaxy's beating heart. A reminder that even in the vast quiet of space, our home orbits something extraordinary. But how do we see what gives off no light? How do we observe something that swallows observation itself? The answer lies in indirect vision, the art of reading the universe by its fingerprints. We can't see the black hole, but we can see how it bends light from stars behind it, a phenomenon called gravitational lensing. We can't touch its surface, but we can measure the X-rays and radio waves emitted by matter heating up as it falls in. We can't feel its pull, but we can track the dance of stars that orbit something invisible at the galactic core. Like detectives at a cosmic crime scene, we follow the clues left behind by gravity. And from those clues, we reconstruct the unseen. Modern astronomy has become a symphony of data. Radio telescopes catch waves longer than buildings. Space observatories pick up gamma rays from across the cosmos. And deep in underground labs, detectors wait silently for the tremor of a gravitational wave, the faint ripples in space-time created when two black holes collide. In 2015, we finally heard those ripples, a brief, rising tone, lasting less than a second. It came from two black holes merging more than 1 billion light-years away. For the first time, we didn't just see the universe, we listened to it. That sound, that single note, was the echo of space-time singing. Proof that gravity, too, can make music. But seeing deeper into the cosmos requires more than telescopes and detectors. It requires something profoundly human, the power to simulate. Our computers have become extensions of our imagination. They model what we can't observe directly, turning equations into landscapes, data into color, theory into vision. Supercomputers simulate the swirling disks around black holes, the jets of plasma shooting from their poles, the flickering light shaped by relativity. Every pixel of the M87 image was refined and verified through countless simulations, each testing a different configuration of space, matter, and magnetism. We can't look inside a black hole, but through these models, we can understand what happens there almost as if we've been inside. The same machines that once calculated orbits now recreate entire galaxies. They run for months, mapping the universe second by second, particle by particle. In those quiet data centers, the cosmos comes alive again, not through eyes, but through thought. And the deeper scientists go, the more they realize something remarkable. To describe a black hole perfectly, we must unite two worlds that have never agreed: general relativity and quantum mechanics. One governs the large, the other the small. But black holes are both. Their gravity is immense, their scale cosmic, and yet the physics at their core is subatomic, governed by uncertainty. The effort to merge these two has become one of the grand quests of modern science, the search for quantum gravity, a single framework to explain everything from quarks to galaxies. Black holes may be the testing ground for that unification. They are where the equations of Einstein and the probabilities of quantum theory must finally speak the same language. If we can solve them, we may not only understand black holes, we may understand reality itself. But there's something quietly poetic about all this effort, the way human beings, tiny creatures on a small blue planet, dare to reach across millions of light years just to glimpse a ring of light around darkness. It took thousands of people, hundreds of telescopes, years of work, and yet the reason behind it all is so beautifully simple. Curiosity, the desire to know, to not just look up, but to understand what we're looking at. And in that sense, every image of a black hole is also a portrait of us, of what we can achieve when imagination meets precision, when patience meets wonder. So perhaps we don't need to see everything directly. Perhaps the beauty of the universe is that some of it will always stay hidden so that we can keep searching. Because what drives us is not the certainty of answers, but the joy of pursuit. Even when light cannot escape, we find ways to trace its echo. Even when time bends, we measure its curve. Even when darkness hides, we illuminate it with thought. That is what makes us human. Not our size, but our sight. Not our eyes, but our imagination. In the end, it doesn't matter that black holes cannot be seen, because we have already touched them in equations, in data, in dreams. They live not just out there, but in the stories we tell, the images we create, the questions we dare to ask. The journey began with a question. Where does everything go after crossing a black hole? It sounded like a mystery about matter, about physics, about the unseen. But now, after falling through gravity's silence, after glimpsing new universes and the limits of thought, we realize that the question was never really about black holes. It was about us. Black holes are not just strange objects in space. They are mirrors, perfect reflections of our curiosity, our longing to know what lies beyond the horizon. Every time we stare into one, we're really staring into our own need to understand. And in their silence, they answer us not with words, but with wonder. They teach us that knowledge has edges, that even the sharpest minds, even the most elegant equations, can go only so far before they dissolve into mystery. For centuries, we've built telescopes, we've sent machines into the void, we've written the language of the stars into mathematics. And yet, here at the threshold of the black hole, we encounter something that cannot be solved. Not because we're not smart enough, but because reality itself seems to whisper, some truths are not meant to be possessed. And that's not failure. That's beauty. In a way, black holes remind us of humility. They remind us that the universe does not exist for our comprehension. It existed long before we were here to name it, and it will continue long after we are gone. We are guests, temporary sparks in a vast and ancient sea of time. And yet, somehow, in our brief moment, we dare to look into infinity and ask it to explain itself. That audacity, that fragile, stubborn curiosity is perhaps our greatest light. Think of how much we've done just to see a ring of light around darkness. Thousands of people working together, across continents, across years, for a single image of something that cannot be photographed. It's almost absurd, and yet profoundly human. We chase the invisible. We build theories from silence. We reach for meaning in the void. And when we finally glimpse it, we find not chaos, but symmetry, elegance, and stillness. It's as if the universe were saying, "You've been part of this beauty all along. You just needed to notice." In that sense, black holes don't destroy meaning, they expand it. They take our certainties, stretch them until they snap, and leave us standing on the edge of comprehension. And from that edge, we learn to see again. We learn that what we call the end might simply be a doorway, that what we call nothing is full of potential we can't yet name. We learn that absence can be presence, and silence can be revelation. If you listen closely, you might feel that the universe has a rhythm, not a heartbeat exactly, but a pulse made of motion and stillness, creation and collapse. Stars are born, they shine, they die, and from their ashes, new stars rise. Galaxies drift apart, then merge again. Worlds appear and vanish. Everything moves, everything transforms, and yet somehow the pattern continues. It's as if the cosmos itself breathes. In, out, birth, death, expansion, return. Black holes are part of that breathing, the moment of exhale, when everything collapses inward, only to be reborn somewhere else, as we've imagined in the universes beyond. So perhaps the question, where does everything go, no longer needs an answer, because maybe nothing ever really goes anywhere. Maybe everything is just changing shape, traveling through different forms of being, different expressions of energy and space. And maybe that includes us. Our bodies are made of ancient stardust carbon and oxygen forged in stars that died billions of years before Earth existed. Our thoughts are patterns of energy that ripple through the same physics that shapes galaxies. We are, quite literally, the universe looking back at itself, the cosmos asking its own question. And so, when we gaze into a black hole, we are not outsiders, we are participants. We are the echo of infinity trying to hear its own voice. There's a strange kind of peace in that realization, that we don't need to own knowledge, we only need to experience wonder. That understanding isn't about conquering the universe, it's about belonging to it. The closer science gets to truth, the more it begins to sound like poetry. And the more poetry searches for meaning, the more it begins to sound like science. Both are languages of awe. Both are ways of saying, I am here, and I'm listening. If we could strip away all the noise, the math, the data, the theories, what remains is something simple, the feeling of connection, the realization that everything, every photon, every atom, every breath is part of the same unfolding, and that we are not apart from the universe, but expressions of it. Moments of consciousness rising and falling like waves in a cosmic sea. When you think of it that way, the fear of the unknown fades. The darkness no longer feels hostile. The horizon no longer feels like an end. Because you understand that beyond every boundary is simply more of the same vastness that gave birth to you. You don't need to cross it to belong to it. You already do. So, if everything disappears when it crosses a black hole, where does it go? Perhaps nowhere. Perhaps it never leaves. Perhaps it becomes part of the same silence that holds the stars together. The same silence that holds you right now in this quiet moment. Listen to it. It's still speaking. Softly. Endlessly. You don't have to understand everything. You don't have to solve every mystery. It's enough to have looked up, to have wondered, to have reached this far. The universe will go on keeping its secrets, but in the act of seeking them, we've found something even greater. Ourselves. Our curiosity, our fragility, our capacity to dream. That is the true reflection the black hole gives us back. Not destruction, but awareness. Not emptiness, but connection. So, close your eyes now. Let the vastness hold you. The questions can wait. The stars are still turning. The galaxies are still singing, far beyond the reach of light. Everything is continuing, exactly as it should. And you are part of that continuation. A moment of infinity folded softly into the story of time.